So let's practice solving for the sides of right triangles using our trig functions. All of this is absolutely positively all about figuring out which trig function you need to use and then understanding how to use your calculator to do that. So for starters here, I'm just going to go through and pick the trig functions for these two problems. We're not going to solve yet. We'll come back and do that. Identify your reference angle. In this case, that's this angle. Angle T is my reference angle because that's the angle measure I know about. From there, identify the two sides that you're dealing with. Start with the variable side because I might give you all three, but you're trying to solve for x. You're trying to solve for this side. That's the hypotenuse. Now you need a second side length. In this case, that's 10, which according to my reference angle is my opposite side. So now I know I'm using the opposite side in the hypotenuse. You have to decide which trig function do you use then. Well, if I'm dealing with the opposite in hypotenuse, that's the sine function. So I set up my trig function. I set up my trig rule here. The reference angle always goes inside. That's my 28-degree angle. And with the sine function, the opposite goes in the numerator. The hypotenuse goes in the denominator. That's a huge, huge step, being able to just set this up. Okay. Let's do that again over here. Again, angle T is my reference angle. I'm doing 28 degrees. Again, I have the hypotenuse, but now I have my variable over here on this side. That is not opposite my reference angle. That is next to it. That is adjacent to my reference angle. So this time my trig function is different. Now it's not opposite in hypotenuse, it's adjacent in hypotenuse. That's the cosine function. So I set up that function, that trig rule, reference angle inside. The adjacent side goes in my numerator. The hypotenuse goes in my denominator. Now I'm not going to go through the algebra of solving the difference in the algebra and solving these two. I'm not going to show all those steps. Come in and go over those with me if you're confused, but just I'll walk you or talk you through it. X is my denominator, so I would have to get it out of my denominator by multiplying both sides by x, giving me x times the sine of 28. Then to solve for x, I would divide both sides by the sine of 28. What winds up happening is I get x equals 10 still my numerator, but the sine of 28 degrees becomes my denominator. That's what I'm typing into my calculator, just like I see it. Please remember in your calculator, before we can type these in, make sure it is in degree mode. You press your mode button. Mine right now is in radian mode right here. I need it in degree mode. I have to scroll down and over, press enter. Now it's in degree mode. I can type this into my calculator and get the correct answer. I type in what I see. I see 10 divided by the sine of 28. That matches exactly what I have here, and I hit enter. X is a side length. We are rounding our side lengths to the nearest tenth, so we're going to say that that hypotenuse has a length of 21.3. The difference in the algebra on this one is the y is in my numerator. So in this case, I just have to multiply both sides by 12. That's going to get me y equals 12 times the cosine of 28 degrees. I don't have to check or change my calculator this time because I already did it once. You do want to check that every time you turn your calculator on to make sure it didn't reset into radian mode. But once it's on there, and you're going through a worksheet or you're going through your test or your quiz, you don't have to do it a second time unless you're not comfortable and you want to check it a second time. But here, I'm just going to type in 12 times the cosine of 28 degrees. I get my answer. 10.59 means it's going to be 10.6. Okay. These next two I'm going to do quickly. Set up my trig functions. Here's my reference angle. My variable is the adjacent side. The side I'm using, that I know, is opposite. I'm not using the hypotenuse. That's the tangent function of 28 degrees. opposite divided by adjacent. The second one looks the same because I have z, I have 12, and I have 28, but the 12 is now my adjacent and the z is my opposite. I'm still doing the tangent function. I still have the same reference angle, but my ratio is now different. Z is opposite, it goes to the numerator. 12 is adjacent, it goes to the denominator. So solving is different. Again, I would multiply both sides by z and then divide both sides by the tangent. I wind up with 12 over the tangent of 28. This case, I just multiply by 12. I get z equals 12 times the tangent of 28. Go ahead and press pause, plug those into your calculators, please. 12 divided by the tangent of 28 should get me 22.6. And 12 times the tangent of 28, 6.4. Again, that's z, just a little typo there. The last type we want to talk about is I want to find this side length. I can't use a trig function right now. I don't have a right triangle. We're not using any of these trig functions unless we have a right triangle. So our job is to make a right triangle first here. It's really important that we can now make a right triangle by dropping down an altitude. When we do that, we now have our right triangle over here. I have a side length of x. That altitude of an isosceles triangle bisects the base. So this is a length of 10, that's a length of 10. We also know in an isosceles triangle that if my sides are congruent, my legs are congruent, my base angles are congruent. So I know this is 72 degrees. I now know enough. Looking at that triangle separately, I have a 72 degree angle, a right angle, a side length of 10, and an x. I can do my trig functions here. Reference angle, adjacent, hypotenuse. That's my cosine function of my angle, and it's equal to the adjacent divided by the hypotenuse. My variable is in my denominator. When I solve this, I am going to divide the cosine of 72. And when I do, I get 32.4. Again, if this is confusing, if you're struggling, please come in before school, come and get that extra help.